Hello. Noise in the background often introduces difficulties in listening. Previous studies have shown that such listening difficulties may lead to mishearings, misunderstandings, and even communication breakdowns in extreme cases. Thus, error mitigation strategies such as Lombard speech are quite useful for attaining communication goals in such adverse listening environments. However, studies on Lombard speech have showcased evidences that their benefits do vary with other linguistic factors such as predictability. Another line of research based on dialogue repair mechanisms have explored the benefits of repetitions and clarifying expressions for mitigating some of these errors. In this work, we proposed an alternative error mitigation strategy based using lexical paraphrases. Our hypothesis is that by replacing lexical units by their noise-robust synonyms, comprehension errors introduced by mishearings can be reduced. The strategy is motivated from earlier findings that the masking effect of a particular noise is not the same across all lexical units. In addition, prior work on word intelligibility have showcased evidences that lexical characteristics of a word, such as the word familiarity, neighborhood density, influences its recognition. For this work, we identified two main research questions. First, to validate our hypothesis, we asked this question: do synonyms exhibit differences in intelligibility under different adverse listening environments? Next, to make use of such a strategy, we have to identify the significant features that drive such intelligibility differences. Let's see how did we attend each of these questions. At first, we conducted a single word listening experiment by considering a set of synonym pairs. These pairs were split into different lists of spoken words, and we ensured that every spoken word was listened by at least 5 different listeners. Stimuli for this experiment were generated using a TTS, and additive noise mixing was performed to generate the noisy spoken words. In total, we had 3 listening environments, a clean and 2 noise environments, where we used the babble noise at 2 different SNR 0 and -5 to simulate this. The participants for this experiment were recruited from a crowdsourcing platform, Prolific, and they were instructed to listen to these spoken words and transcribe what they heard. So after collecting user responses for this stimuli, we calculated the intelligibility score for each of this word under different listening environments. We call this as human recognition score, which is basically the proportion of correct recognitions among all its responses. Hence, this value ranges between 0 and 1. Since we are interested in capturing the impact of lexical replacements in comprehension, we calculated the absolute difference of HRS between a word and its synonym. Again, this value ranges between 0 and 1, 1 representing maximum impact of lexical replacement in comprehension. Let's see what did we capture from our first experiment. What you can observe here is on the x-axis is the difference in HRS between synonyms, And on y-axis is the percentage of synonym pairs that belongs to each of the spins. In clean environment, we didn't observe many synonyms that are distinct in their recognition scores, since most of the words were recognized correctly. But that's not the case in other two noise environments. We observed that with increase of noise in the background, there is a steady increase in synonym pairs that are distinct in their recognition scores. At this point, we were curious to find, could this intelligibility differences between synonyms remain same if they were presented with linguistic context? That's when we conducted the second set of listening experiment, short utterance listening experiment, by considering 91 paraphrase pairs. These paraphrases were generated by performing lexical replacements. Again, we generated stimuli for this experiment by using a TTS and performing additive noise mixing. We considered 3 listening environments. Here, instead of clean environment, we used SNR5, a low noise environment. This was mainly because at clean environment, we observed ceiling effect. And participants from Prolific were instructed to listen to this whole utterances and transcribe what they heard. Just to give you an idea about this stimuli, let me play one for you.
You did not even say it correctly that time.
Yes. So that's one of the example, and we asked participants to transcribe. Then further, we calculated the HRS scores for each of the target words. After calculating these HRS values, for every synonym pair, we split the words in synonym pairs as either a more intelligible synonym or a less intelligible synonym based on these values. Let's see what did we observe between these two classes under different listening environments. So the red one represents the less intelligible synonyms, and the blue, more intelligible synonyms. In case of SNR5, the low noise environment, we didn't observe much of difference between these two classes. Like in the previous listening experiment, we saw with the increase in noise in the background, the distinction between these two classes increased steadily. More precisely, at high noise environment, we observed there's a higher gain in intelligibility by performing lexical replacements, even when synonyms were presented with linguistic context. So to summarize our listening experiments, we observed that synonyms exhibited recognition differences in noise, even when they were presented as isolated or with linguistic context. And in case of short utterance listening experiment, there is this gain in comprehension of 21% at SNR 0 and 37% at SNR -5. With this, we believe that the proposed strategy is a promising approach to improve comprehension in noise. Now, moving on to the second research question of identifying significant features that drive intelligibility differences under different listening environments, we conducted modeling experiments using linear regression models. For this, we considered 3 existing metrics motivated from prior work as predictors of these models. First is the linguistic predictability, as prior work on speech perception in noise has shown that intelligibility of a word is influenced by its predictability in noise. Next is the length of phonemic transcript of a word, which has been discussed in several past studies that longer words are easy to recognize. And third is a well-known speech intelligibility metric called STOI, which calculates the long-term correlation between a clean speech and a noisy speech. At first, we considered these features for explaining the variance in word intelligibility under different listening environments. Let's look at the model outcome. So in this table, what you can observe is the model predictions for coefficients of each of these features as well as the intercept and their respective p-values, which indicates the significance of a particular feature for that environment. So what's interesting for us is that under low noise environment, we observed the predictability of a word is significant for its intelligibility. However, under high noise environment, where the noise masks a target word as well as its context, it is the STOI as well as the number of phonemes significant for determining the target word intelligibility. So after observing this distinction between linguistic and acoustic features, we further continued our modeling experiments to study could these features explain the differences in synonyms intelligibility differences as well. So to this end, we considered the differences in linguistic and acoustic features of synonyms as well. And what we observed was in case of low and medium noise environment, the synonyms intelligibility difference is mainly driven by linguistic features. However, under high noise environment, it is the acoustic feature that drives the intelligibility differences. So more precisely, this is indicating that the gain in intelligibility that we observed under high noise environment is mainly contributed by the lexical replacements. With that, I would like to conclude my talk with main highlights of our work, that we proposed a novel strategy to improve comprehension in noise by performing lexical replacements. And we observed that such lexical replacements exhibited a higher gain in comprehension at high noise environments such as babble SNR -5. And from our investigations on identifying significant features, we observed that at high noise environment, the intelligibility difference between synonyms are mainly driven by acoustic features, whereas at low and medium noise environments, this intelligibility differences are driven by linguistic features. Thank you.